Hello, everybody. So, this is me again, Rich Andre, and I'm going to be talking about some of the basics of electrical engineering. I believe this is the fundamentals to which a lot of the topics that are discussed in relation to electrical engineering is formed upon. is forged upon. Sorry. So, this is going to be just very basic stuff. And the information I got this from the source that I got this information from is from Khan Academy. Okay, so thank you, Khan Academy, for giving me a great sort of overview on what the basics of electrical engineering are. And today I'm going to share that information with you. Okay, so the very basic thing that we need to know when we're diving into electrical engineering is currents. Okay, the first things is currents. So if you can imagine a little atom right here, let's say a copper atom. Okay, we could imagine a little copper atom right here, and we can see here, we can draw out the multiple fields, in which the electrons are located. Okay, so you can imagine that this is the copper atom. Okay, so this is the copper atom. This is the copper. This is the atomic number for the copper atom. You can see right here. This is the atom itself, and this is the fields that have electrons in them. So a copper atom has 29 protons. Okay, 29 protons there, and 29 electrons. So we could imagine the electrons here. There are electrons there. There are electrons there. Then we have the very farthest part in which the electrons could be located in this copper atom. That electron, okay, that particular set of electron is the electron that could be sort of extracted, that could be easily extracted from the copper atom, and that's when we get to currents. Okay, that's exactly where we get to the concept of currents. When we extract an electron atom, an electron from a copper atom, we can use that electron in order to create positive or negative charge. Okay, so we can imagine here we have a copper wire. Okay, you can imagine that this is a copper wire. Okay, so there should be let's say you have a battery right here. Hold on. Let's say you have a battery. Okay, let's say that this is your battery. Okay, so you have to connect the battery to the copper wire. Okay, and copper wires, and anything copper in particular, okay, they are very conductive. They're very conductive materials, and that just basically means that there is high potency for electricity to be sort of created. Okay, to be sort of created in that environment. So we have a copper wire right here. We have a battery right here that is plugged on the both ends of the copper wire. So we could imagine that the copper wire, inside the copper wire, there are electrons. Okay, so you could imagine that there are electrons. There are swimming inside this copper wire. And I'm just going to write it as negative signs, because an electron, as you guys may know, okay, an electron has a negative sign. An electron no, an electron has a negative charge. Okay, so we can imagine that there are electrons swimming in this copper wire. Okay, and there are also positive charges that are swimming inside this copper wire. So if you could imagine that there's a battery right here. Okay, of course on both sides there are going to be positive and negative. So in the concept of currents, we have to imagine a sort of imaginary line bound to the copper wire. Okay. In order for us to further understand, in order for us to kind of simplify the concept of currents, we just have to imagine a sort of imaginary line that could be at any point or at any place that could be at any place of a copper wire. Okay, so we can imagine this. There's an imaginary line right here. If we hypothetically like zoom in, okay? If we hypothetically like zoom in, let's say that this is you, okay? Let's say that this is you, and you're looking at the copper wire. There is an imaginary line, the copper wire. Since the left side, from our perspective, of this copper wire is positive charge, and the right side is negative charge, we're just going to see what kind of okay. So before we come into the concept of currents, we have to first realize that charges, okay, they either attract or repel each other. So you have a negative, you could say that you have a positive charge right here, and then another positive charge. They are going to repel each other. If they are the same charge, they are going to repel each other by default. Okay, but okay, if you have say a negative charge, okay, if you have a negative charge and a positive charge, they are going to attract each other. So that fundamental point of contingency can be used when we're talking about currents in this copper wire, and in terms of this and in terms of this imaginary boundary line that we drew right here, we could imagine that you are the size of this man. There's a copper wire that you are standing on. If you could see like the insides of this copper wire, the electrons that are moving through it, you can see that through this imaginary boundary line, okay, there are positive and negative charges that are passing through it. Okay. So if the left side is if the left side of this copper wire is a positive charge, okay, since the battery is right here, okay, the long side of the battery, okay, the long side of the battery is also going to be a positive, and the short side, okay, the short little line that you see right here is going to be a negative side as always, okay. So since the left side of the copper wire is a positive charge, okay, then obviously it's going to attract positive charges, okay. So you're going to see positive charges that are going to this direction, going to the left direction. You're going to see positive charges that are going to the left direction. Okay, and then you're going to see, since the right side of the copper wire is a negative, you're also going to see some ions moving to the right side. Okay, the positive ions moving to the right side. So hold on, let me just use the okay. So going here, okay, the negative electrons are going to the right side, to the left side, because it attracts the positive, okay? And the positive ions are going to the right side, okay? Because they're positive, and positive breeds negative. So if you imagine this little boundary line that you have right here, and you counted every single one of these charges that are going that are passing this imaginary boundary line, okay, that could be at any point or place on the copper wire, the conductor, you could calculate the current, okay? From there, you can calculate the current. And that the calculation is basically just this, okay? So the current is basically just this sign. Okay? So this means that that current is basically just charge per second. This is the sign for charge, and this is going to be the time. This is going to be the time in which you calculate just how many of those little particles, little positive charges are going. Okay. how many of them are passing this boundary line, regardless of whether it is on the right, or passing it to the right, or passing to the left. Okay, they are both included in the sum of the equation. Okay, so now that we've covered what a current is, okay, now let's talk about voltages. A voltages is basically just this. Okay, there are voltages on the left and right side of the copper wire. Okay, so um, now let's distinguish the two types of basic currents. Okay, so um, from my own understanding, okay, there is a current. Let me just, okay. The conventional currents, they always go right. Okay, and what do I mean by conventional currents? The conventional currents is basically just what we mean by currents in general, because currents are supposed to be positive. Okay, so we base that on on behalf of the discovery of Benjamin Franklin. Okay, he's basically the one who conceptualized that the current is always going to be to the right. Okay, it's always going to be to the right, because the positive charges, okay, positive charges go to the right side because there is a negative charge right here. Okay, so they both attract each other. That's going to be called the conventional, okay, conventional current. Meanwhile, the electrons that are going to this side, okay, to the left side of the copper wire, that is what we call the electron current. That is what we call the electron current. As you may already know, the electrons, okay, they are negative charge, so obviously they're going to be attracted to the positive charges. Okay. So now we're going to talk about just a little overview of circuits. Okay, so you can imagine the way that currents, the way that the voltages and currents work. Okay, we can imagine a mountain. Okay, and I'm using this analogy from the professor who created this course on the Khan Academy. Okay, you can imagine a mountain. Okay, at any point in this mountain, let's say you have a ball. Okay, say you have a ball, and you put this ball right here. This ball, okay? Let's say you put the ball right here. Obviously, this ball is going to go downward, okay? And all that potential energy from the ball will turn into kinetic energy, and that ball will go downward, okay? So it's the same thing with the concept of currents, okay? So if we could imagine the same mountain again, and let's say that this is the electron, okay? The ball is an electron. And we have a battery right here. We have a battery right here. And it's plugged to this. Okay? Okay, so let me just see here. Let me just go back here. Okay. So the way that this will work, okay, the ball or the electron will go downward. It will go downward, and if you go back to the ball analogy earlier, the ball obviously, okay, in a mountain you can imagine that there are trees in there, there are bears in there, there are several rocks that could be hindering the sort of downward flow of the ball. And the same concept, the same analogy, or the same thinking could be applied to the way currents work. Okay, so we can imagine an electron right here. Okay, so let's say you have a resistor. Okay, these little squiggly lines that you see here, they could be anything. Okay, from my own understanding, these little squiggly lines, if you think about it, okay, if you think about it, it's sort of like obstacles that the ball has to go through before it goes back, before it goes down. Okay, so we can imagine this to be anything like a resistor, which basically controls the voltage of batteries. Okay, so you can imagine this as like obstacles until the electron and basically the electron just moves downward. Okay, it just moves downward and goes back to the battery again, and it's sort of like it's the concept of currents is sort of like this. Okay, it's basically just a continuous spiral, and this is the battery right here. The electron is going to travel there, all the way up here, and then back here. Okay, so that's basically a brief overview of a little bit of the basics of electrical engineering. I'm not sure if I explained this part as clearly as I should, but hopefully I was able to give you a little bit of an idea of how some circuits works, how electrons move through currents. Okay, so thank you guys for watching. You know, of course, this isn't going to be the only video I'm going to make about this. This is actually uh, a really interesting topic, if I do say so myself, because this is the fundamental basics of electrical engineering, and you know, uh, that's going to be basically it. Okay, so thank you guys for watching this video. If you liked it, please subscribe. You know, please subscribe. Give me a thumbs up. If you didn't like it, please give me some feedback. Okay, give me some honest feedback in the comment section, and I will be sure to read it. So thank you guys for watching, and stay tuned for another video, especially a part 2 of this. There is going to be definitely a part 2 of this. So thank you guys.